Show the mechanism of how the following reaction takes place. Sure. Okay, so let's do that. Here we have an alkene and we are adding HBr to it. Okay, so let's get started with this. So the first step is, of course, the alkene, which is the base. It's going to go ahead and pick up a proton. And so then you have the ring here. And I'm just going to flip this, or maybe not. Okay, that's all right. I can leave that. So when it picks the HBr, okay, that's going to be Markovnikov addition. And the carbocation that I'm going to form is going to be the more stable carbocation. So hydrogen goes over here. Okay, and now this is where the magic takes place, because as soon as I have a carbocation, I need to start thinking about rearrangements. Is rearrangement possible or not? And in this case, rearrangement is possible because I have a methyl group on the carbon next to it. So this carbon, I will move this methyl group onto this carbocation over here, so which means that my carbocation is going to shift. Okay, and why am I doing this? The only reason I'm going to do this is because the product that I'm going to form is going to be a more stable carbocation. Okay, so that's what happens over here. So now if you were to just use this carbocation to form your product, first of all, you will not form your product, okay, because the bromine is not even there on the outside of the ring. It's actually on the ring, okay, so which means that there has been some shifting going on with the carbocation, okay. And so once you have your carbocation that's shifted, so now you can go ahead and add the bromide and do this. Okay, and so now we are all okay because the carbocation is also happy. And here I'm going to go ahead and write that we actually did a methyl shift. Okay, so that we will remember that whenever you have a carbocation, you have to look into and seeing if there is any more stable carbocation that's possible.